Okay, this is TempleOS 5-minute random code walkthrough episode 26, and I'm your host, Terry Davis. So let's see where God takes us. Alt B. And we are in compiler statement parser. Wow, at the top. That's kind of a strange location. So this is the compiler, the first phase of the compiler after Lex, I guess. Anyway, what we're looking at right here is where it creates a new class. So let's say you have an i64 in the symbol table are the symbol table has several types of entries. Global variables are in the symbol table. Data type classes are in the symbol table. The internal types are in the symbol table, and functions are in the symbol table. So these are the main entries in the symbol table. The assembler puts export symbols in the symbol table. So the way a class is implemented is we have a structure for a class that includes the base structure for all source symbols. That's the parent class. Anyway, this includes a class has a list of members, member count, and it has a base class. It might have a forwarding class. It has a linked list of members in the class. So a pointer to a class. Here's what I do for a class. When I define a class, I define you can have a maximum of 4 stars, pointers to pointers to pointers to pointers. Anyway, so what I do is I make a node with 5 classes together. They're one right after the other. And what I do is, I should have kept that. So there's a structure with, that's not what I should show. What I should show you is, well, this is, I know what I can do. Oh well. So what we have is 5. We have a structure with 5 of these, and 1, 2, 3, 4, 5, 6. I did 6. Anyway, and from now on, when we talk about a pointer to a class, if it's the class itself, we point here. If it's a pointer to a class, we point here. If it's a star, we point here. If it's a star, we point here. So we can have up to 4, and so once we when we parse a class, it turns out that a function has a member list very similar to a class with a member list. So I use the same routine to parse a function header. So a function header is very similar to a member list in a class. If you look at a function header, so I use the same parser routine where parse var list, So in a class or in a function, we call parse var list, and parse var list starts with a for a function it starts with a parenthesis. For class it starts with the brace. Then you parse the types and the names until you get to the end, and at the end, this is in a loop until we hit, I guess if we get, it's done when it hits so when it hits a parenthesis or right brace, it's done. That makes a linked list. Okay, so we have a pointer to the end of the linked list. So this is we don't make it a stack, we make it in order. So when we add a member variable to a class, we add it on the end, and we record the size of each class. When we add member variables, we increase the size, there's a raw type. What this is let's say if you make a class, I don't know, I think what I do is hold on a sec. In the kernel, I do bit fields a strange way. So if you have a U16, a union, a U16 is a union of two signed bytes or two unsigned bytes, and taken together, it's a U16I internal. This is a new syntax. Instead of handling bit fields the normal way, this handles this lets you access bytes or subbytes in a bigger integer. These are all integers when treated alone, but you can access the subfields in the integers, and I'm pretty sure that's what we were looking at, is raw type. This is a pointer, starts out as a pointer, but for some classes it's the whole thing together is a U8 or a U16. Anyway, oh well.